College's Industrial Process Control. This video is Lab 2, Continuous Level Measurement. This is the second part of the lab where we actually take measurements using a continuous method as opposed to point-to-point. This lab uses a transmitter and a PLC to control the pump. Once the set point has been satisfied, the system continues to constantly adjust the control variable to correct any set point process variable errors. Notice that transmitter LT1 has two different input signals, air and hydraulic, water. Also notice that LT1 continually sends a signal regardless of the set point process variable condition. The process piping and impulse lines remain as they were for the calibration lab. Electrically, this system has been simplified since it does not require two input signals to indicate level, but rather a single signal from the transmitter to the PLC control element. The transmitter continually updates the PLC with the current pressure, and if no pressure is detected, it still sends a 4 milliamp signal, unless itself has failed. Notice too that the digital multimeter has been removed, since its function has been absorbed by the PLC. It is no longer needed.
Okay, so in this lab what we have is a proportional control, which means that the corrective action isn't constant, it isn't the same all the time. And it also too takes into account what the error is. So as the error becomes greater, the corrective action becomes greater. So we bring it back in line with the set point. So we have this proportional control. We measure the level in the tank by this pressure transmitter. Now the pressure transmitter measures the pressure at the bottom of the tank. It is not directly measuring the level of the water. So this is an indirect level measurement. This transmitter actually translates what the pressure measurement is at the bottom and gives an output to our control which is directly proportional to the level. It's an analog signal, 4 to 20 milliamp signal. It's coming from our transmitter going to our controller that reports this level, and our controller is set up so it will provide a proportional output to our final element. Final element in this case is the motor and pump combination. Our primary element is an integral part of this transmitter. The transmitter is a pressure transmitter and it's going to the PLC. Now as you can see here, you have the water level. We have a set point and it is maintaining that water level and it can be changed. So I'm going to change it through the control and bring it down just a little bit.
In the last lab, we calibrated our transmitter so that we had a lower range value of 2 inches and an upper range value of 20 inches. Without touching the knobs, we rewired it to be controlled by our HMI and our PLC. So the first step you're going to do is turn the system on. You're going to hit continue and you're given 4 menu choices. So we want level. We've already done the point level lab, so that won't be necessary, but we do want to do the continuous lab. When we turn on, you can hear the motor should start to sound like it's trying to run. It's not running because we don't have a set point. So right now our process variable says it's ridiculously high because we're in what we call a fail high mode. Fail high mode is a default setting of the Omron PLC used in the lab. With fail high mode, the PLC resolves ambiguous states by changing the process variable value to the maximum possible positive value in the PLC's design. This high value is then applied to the program, and since the process variable is greater than the set point, the entire process stops. So what we want to do is we want to plug in a new number, and we're going to watch the screen, and then you will verify that you're actually getting the correct amount of water column. If you have not calibrated it correctly, you're on your own. Okay, so let's start off. What you're going to do is you're going to go to the set point. It's actually not only a display but a push button. It'll come up with a small menu. So we're going to type in 15, enter, and the motor's turning to pump. I see water filling in. And now it's going to try to maintain that 15%. This value will shift between 13 and 14% as it tries to maintain that.
I'm going to bring it, right now it's set for 75%. So go, then I change the water level by the control. And I've set it to 50%. And the water level is dropping. And it gets down low, and now what it's done is it's maintaining a level. Now what we see is, what we're going to see is what happens with this type of level measurement, or pressure, using a pressure transmitter. I'm going to move the pressure transmitter, and I'm going to see what the effect is on the level. So, undo it. I move it sideways, I drop it down, and what you'll hear, or what you'll see, is that the level actually now is dropped down. I move the transmitter down, the level dropped. The reason being is it's measuring pressure. What I did by dropping it down, I had greater head of water above the transmitter. It was reading a greater pressure, thinking that the water level was higher than it actually was. Once I move it down, the control goes, hey, the water level's too high, I've got to bring it down. I'm going to move the transmitter back to where it was, and in fact, by doing so, I'm reducing the amount of pressure that's coming into the transmitter. And now it's back to originally where it was. This is a pressure transmitter, so it has to take into account hydrostatic pressure from the top of the liquid to the port on the transmitter. Now, if you have to move this transmitter, it is very important that you recalibrate. You have to recalibrate the transmitter for the new level. So always keep this transmitter on the same level that you originally installed it on. If you have to move it, you have to recalibrate.